In the present discussion, we have to talk about generating function of Pn of x. Consider the function 1 minus 2 xz plus z square power minus half. With the help of this function, we can generate the legendary polynomials P1 of x, P2 of x, P3 of x, and so on. This function is equal to summation over n equal to 0 to infinity z power n Pn of x. Put n is equal to 0 here, we can get the first term z power 0 P0 of x. If you put n is equal to 1, we can get the second term z power 1 P1 of x, and so on. We know that the P0 of x equal to 1, then anything for 0 is also 1. So this is 1 plus z1 P1 of x, z square P2 of x, and so on. Therefore, with the help of this function, we can generate polynomials P1 of x, P2 of x, P3 of x, and so on. Only due to this reason, we are calling this function as a generating function of Pn of x. Now we have to prove the same. For that, we should know the binomial theorem. Now find out the value of 1 minus e power minus half using binomial expansion. Find the value of 1 minus e power minus half using binomial expansion. You know the expansion process, 1 plus x power n equal to 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 into n minus 2 divided by 3 factorial x cube, and so on. The series is going on. Now, we have to expand this using that formula. 1 minus t power minus half equal to 1 plus nx. Here the value of n is minus half, x is minus t, plus n into n minus 1, that is minus half into minus half minus 1 by 2 factorial x square, that is minus t whole square. Next term n into n minus 1 into n minus 2 whole divided by 3 factorial x cube, that is minus t whole cube, and the series is going on. If you simplify this, 1 plus 1 by 2 into t is the first term, because minus into minus plus. Then there is minus 3 by 2, minus 1 by 2 into minus 3 by 2. All are expressed in positive. 1 by 2, 3 by 2, whole divided by 2 factorial, minus t whole square, that is t square. Here, minus 1 by 2, minus 3 by 2, minus 5 by 2. Minus t whole cube is minus t cube. So, entire is expressed in terms of positive. 1 by 2, 3 by 2, 5 by 2, whole divided by 3 factorial t cube, and the series is going on. Then this can be modified as 1 plus 1 by 2 t 1 dot 3 divided by 2 dot 4. This is 2. 2 factorial is also 2. So 2 into 2, 4 t square plus 1 dot 3 dot 5 divided by 2 dot 4 dot 6. 3 factorial is 6. 2 dot 2 into 2, 4 t cube, and the series is going on, and the nth term is 1 dot 3 dot 5 dot 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 2n minus 1 whole divided by 2.4.6 dot 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 2n into t power n. This is the nth term. See here, if you put n is equal to 1, 2 into 1, 2 minus 1, 1. N equal to 2, 2 into 2, 4, 4 minus 1, 3. Here, if you put n equal to 1, 2, the first term you can get, n equal to 2, next term. So this is the nth term. In this way, we have expanded the value of 1 minus t power minus half. Now we will go to our actual function. Now consider our actual function, that is the expansion term is 1 minus 2xz plus z square power minus half. This is modified as 1 minus z into 2x minus z entire power minus half. See here, 1 I have written as such. Just I have taken out minus z outside. The rest of the terms are 2x minus z entire power minus half. Now we have to expand this equation in this form using 1 minus t power minus half logic. Therefore, t equal to z into 2x minus z. This is the value of t. This is our t. Now we have to expand using this formula. So this value equal to, that means 1 minus 2xz plus z square power minus half equal to 1 plus 1 by 2 into t. The value of t is z into 2x minus z plus 1.3 divided by 2.4 t square, that is z square 2x minus z whole square. Then 1.3.5 divided by 2.4.6 t cube, that is z cube 2x minus z whole cube. Then dot dot nth term. The nth term is 1.3.5 2n minus 1 divided by 2.4.6 2n into t power n. The value of t is z power n 2x minus z power n. This is expansion of 1 minus 2xz plus z square power minus half. Just we have expanded this term with the help of this formula. This is our nth term. Instead of t, we put this t power n, that is z power n 2x minus z power n. Now we will simplify. In the above function, just 1 minus 2xz plus z square power minus half. I have removed this because of the less availability of space. 1 plus this term and the next this term and another term. X cube term is not returned. Then I have returned directly the nth term. Before to the nth term, n minus 1th term should be present. Before that, n minus 2 term should be present. What are the values of n minus 1th term and n minus 2th term? We have to find out. For that, we should take our nth term. From the nth term alone, we can get the n minus 1th term and n minus 2 term. Now we have to make our operation. To get the value of n minus 1th term, put n equal to n minus 1 in the nth term. Now we need the value of n minus 1th term, that is previous term to this nth term. For that, put n equal to n minus 1 in the nth term. Now we can get one dot 3.5 2 into n minus 1 minus 1 z power n minus 1 2x minus z power n minus 1 divided by 2.4.6 2 into n minus 1. This is equal to 1.3.5 2n minus 2 minus 1, that is dot 2n minus 3 divided by 2.4.6 2n minus 2 into z power n minus 1 2x minus z power n minus 1. This is the value of n minus 1th term. In the same way, we have to find out the value of n minus 2th term. To get the value of n minus 2th term, put n equal to n minus 2 in the nth term. We get 1.3.5 2 into n minus 2 minus 1 whole divided by 2.4.6 2 into n minus 2 z power n minus 2 2x minus z power n minus 2. This is equal to 1.3.5 see 2n minus 2 into 2 4 minus 1 5. This is 2n minus 5 divided by 2.4.6 2n minus 4 2 into n 2n minus 2 into 2 4 z power n minus 2 into 2x minus z power n minus 2. This is the value of n minus 2th term. Now we have to include n minus nth term previous to nth term, then n minus 2 term previous to that n minus 1 term, and the series is further expanded. In the last equation, in this equation, in addition to the nth term, we have added n minus 2th term, then n minus 1th term. Before to nth term, n minus 1 and n minus 2 terms are present. Just we have inserted the two terms, nothing new to interpret. Now we have to equate the coefficient of z power n in each and every term. Now we have to find out the coefficient of z power n in the nth term. See, these are nth term. Nth term is 1.3.5 2n minus 1 divided by 2.4.6 2n z power n into the term, that is 2x minus z power n. This is the nth term. This is actually 1.3.5 2n minus 1 divided by 2.4.6 2n z power n into is 2x whole power n minus z power n. This is the meaning for this. 2x whole power n minus z power n. Now if you multiply z power n into 2x whole power n, then minus of z power n into z power n is z power 2n. We have to concentrate the coefficient of z power n, which means that only this term is taken in our account. We are talking about the coefficient. If you make your multiplication, you can get z power n 2 power n x power n. This is the first term minus z power 2n. Z power n and z power n is z power 2n. We are in the position to find out the coefficient of z power n. Coefficient of z power n is only this term. That is 2 power n x power n. Therefore, the coefficient of z power n in the nth term is the coefficient of z power n in the nth term is this term into 2 power n x power n. This is the coefficient. Now we have to simplify this further. This is equal to 1.3.5 2n minus 1 whole divided by, now consider this is 2 into 1, 2 into 2, 4 is 2 into 2, 6 is 2 into 3, and this is 2n, 2n. Here 2 power n x power n. Now we have to modify this further. This is equal to 1.3.5 2n minus 1 whole divided by, see that this 2 is present in terms of 2 power n term n times. If you take the 2 power n times, we can get rest of the terms 1 dot 2 dot 3 dot up to n. So that is n factorial. So the denominator is modified as 2 power n into n factorial, because 2 power n times you can get n. If you take 2 in terms of 2 power n times, the remaining terms are 1, 2, 3 up to n. That is n factorial. So the denominator is expressed as 2 power n into n factorial. This is multiplied by 2 power n into x power n. Now we may cancel 2 power n, 2 power n. So the coefficient of z power n in the nth term is 1.3.5 2n minus 1 divided by n factorial into x power n. The coefficient of z power n in the nth term is 1.3.5 2n minus 1 divided by n factorial into x power n. This is the coefficient of z power n in the nth term, because 2 power n get cancelled. The coefficient of z power n in the nth term is this much 1.3.5 2n minus 1 divided by n factorial x power n. In the same manner, we have to find out the coefficient of z power n in the n minus 1th term. To find out the coefficient of z power n in the n minus 1th term, we have to concentrate this n minus 1th term. We have to take this term. In this term, first we have to expand the term 2x minus z power n minus 1. What should be the value of this term? We have to find out 2x minus z power n minus 1 is equal to 1. Further, we have to use the formula x plus a whole power n equal to x power n plus nc1 x power n minus 1 a power 1 plus nc2 x power n minus 2 a square and so on. This formula we have to use. Here x equal to 2x, a equal to minus z. Now expand this 2x minus z power n minus 1, n equal to n minus 1, n equal to n minus 1 here. X power n, what's the value of x? 2x. This is equal to 2x power n equal to n minus 1 plus n. The value of n is n minus 1. C1, what's the value of x? 2x. 2x power n minus 1. But in our case, n is equal to n minus 1. So here we have to put n minus 2 into a power 1. The value of a is minus z. So minus z power 1, that is minus z. Plus nc2. The value of n is n minus 1 here. Then c2, x value is 2x power n minus 2. Here n is n minus 1, so this is n minus 3 into a square. A is minus z, so minus z whole square. This is the expansion of this term. If you expand this further, you may get 2x power n minus 1 plus n minus 1 2x power n minus 2, because n minus 1 c1 is n minus 1 into z. This minus z is present. The negative sign minus z plus n minus 1 into n minus 2 divided by 1 into 2. This is the meaning for n minus 1 into c2. n minus 1 into c2 is n minus 1 into n minus 2 divided by 1 into 2. Here 2x power n minus 3. Here this is z square, because minus z whole square is z square. This is the value of 2x minus z power n minus 1. Now we have to substitute this value in this term to find out the coefficient of z power n. Instead of 2x minus z, we have to substitute this value. Then we will find out the coefficient of z power n. Now consider the term. We need the coefficient of z power n in the n minus 1th term. This is the n minus 1th term. Just I have written. Instead of this term 2x minus z power n minus 1, we have substituted these values. We have arrived this value and we have substituted this value here. Say 1.3.5 2n minus 3 divided by 2.4.6 2n minus 2. I have written as such z power n minus 1. Instead of this, we have written this value. 2x power n minus 1 plus n minus 1, 2x power n minus 2 minus z plus n minus 1 into n minus 2 by 1 2, 2x power n minus 3 z square. Now we have to equate the coefficient of z power n. For that, consider right hand side. Here, z power n minus 1, no z term is present. We are in the position to equate the quotient of z power n. Now come here, z power 1, z power n minus 1 into z power 1. A negative sign is present, no problem regarding that side. We have to take it outside. Z power 1, which is equal to z power n. Plus 1 minus 1, we may get z power n. So that this term is taken in our consideration. Now go to the next term, z square. Z power n minus 1 into z square is z power n plus 1. That term will not be taken in our account. So the coefficient of z power n in the n minus 1th term is minus, consider this negative, minus 1.35 dot 2n minus 3 whole divided by 2.4.6 2n minus 2, then this term n minus 1 2x power n minus 2. This is the quotient. This is the quotient of z power n in the n minus 1th term. Just multiply with the help of z power n minus 1 to the terms available here. Here only we make it z power n term. So the coefficient of z power n is n minus 1 2x whole power n minus 2. Now we have to modify this term further. Now we have to find out the coefficient of z power n in the n minus 1th term. Further, we have to reduce this term. This is available term. With a negative sign, 1.3.5 2n minus 3 divided by 2.4.6 2n minus 2 into n minus 1 2x power n minus 2 is present. Now we have to modify this. 1.3.5 2n minus 3 divided by 2.4.6 2n minus 2 n minus 1 2x power n minus 2, which is equal to 1.3.5 2n minus 3 n minus 1 2 power n minus 2 x power n minus 2 whole divided by this 2.1, 4 is 2.2, 2.3 dot take to outside n minus 1. This is equal to 1.3.5 2n minus 3 n minus 1 2 power n minus 2 x power n minus 2 divided by, we may express the entire terms in terms of 2 power n minus 1 into n minus 1 factorial. The denominator is written as 2 power n minus 1 into n minus 1 factorial, because the final term is 2 into n minus 1. So 2 power n minus 1 term is taken out as a common term. If you combine the rest of the terms 1, 2, 3 up to n minus 1, that is n minus 1 factorial. This is available with us. Now we have to modify this further. Now for convenient, multiply both the numerator and the denominator by the term 2n into 2n minus 1. This is equal to 1.3.5 dot 2n minus 3 n into 2n minus 1 n minus 1 2 power n minus 2 x power n minus 2 whole divided by 2 power n minus 1 2n minus 1 n into n minus 1 factorial. See here, the numerator is multiplied by n into 2n minus 1. The same operation is carried out in the denominator also, n into 2n minus 1. Here, the value of n into n minus 1 factorial is equal to n factorial. Instead of this, we may put n factorial. For example, put n is equal to 3. 3 into 3 minus 1 factorial, which is equal to 3 factorial. See, 3 into 3 minus 1 is 2. 2 factorial is 2. 3 factorial is 6. So 3 into 6, 3 into 2 is 6, 6 equal to 6. So instead of n into n minus 1 factorial, we may put n factorial. Here we may put n factorial. This is replaced by n factorial. Then think about these two terms. Two power n minus 2 divided by 2 power n minus 1, which is equal to 2 power n minus 2 into 2 power minus n plus 1, which is equal to 2 power minus 1, which is equal to 1 by 2. Just replace these two terms by 1 by 2. So instead of this term, we may put n factorial. This should be replaced by n factorial. Then 2 power n minus 1 and 2 power n minus 2 are replaced by 1 by 2. 1 by 2. So this is a new term we have arrived. We have to simplify this further. From the structure, we have modified this. 1.3.5, 2n minus 3, n into 2n minus 1, n minus 1, x power n minus 2. Then this 2 dot 2n, this is 2. This 2 is present here. 2 dot 2n minus 1 into n factorial. Now we have to modify this further. This is equal to, for convenience, we can write 1.3.5 dot 2n minus 1. No need to take this 2n minus 3 here, because if you put n is equal to 1, you can get the first term. N equal to 2, 2 into 2, 4 minus 1, 3, we can get this, divided by n factorial. This is the coefficient of z power n in the nth term. Then the rest of the terms, n into n minus 1 divided by 2 into 2n minus 1. 2 into 2n minus 1. X power n minus 2. This is the coefficient of z power n in the n minus 1th term. See here, from the above equation we have discarded this term because if you use 2n minus 1 you can get all the series. Rest of the things I have written as such. So this term is discarded. 1.3.5 2n minus 1 divided by n factorial. This is the quotient of z power n in the nth term, commonly present, into, write down the rest of the term, n into n minus 1 divided by 2 into 2n minus 1 multiplied by x power n minus 2. This is the quotient of z power n. In the same manner, you may write the quotient of z power n in the n minus 2th term. In the same manner, we may write the quotient of z power n in the n minus 2th term is, just rewrite this term. This is nothing but the quotient of z power n in the nth term. Then write down this term, n into n minus 1 divided by 2 into 2n minus 1. We have to add n minus 2 and n minus 3 in the numerator, and the denominator 4 into 2n minus 3. This is multiplied by x power n minus 4. This is the value of the quotient of z power n in the n minus 1th term. We can do the same method we have adopted to find out the quotient of z power n in the n minus 1th term. But no need for it, just write down as such. Now we have to combine all the terms in our generating function. That is the quotient of z power n corresponding to the nth term, n minus 1th term and n minus 2th term. We have to substitute all the values in the generating function equation. Now we will carry out.